Hello? Hello, hello, hello? Ow. Hello? Hello? You know, the S in Syzygy does stand for scuffed, so I was not surprised that there would be at least one bug, because today is the very first HANDCAM stream. Is the audio quality good? I had to disconnect my other microphone today because I am unfortunately out of USB to USB. I think this is just typical USB to USB-C converters for this stream. So yes. Hello, how is everybody doing today? I am doing great. Alright, roll call. Hello. Hello, Penbu. Thank you so much for being here. Penbu is my mod. Hello, Alexander Babsky. Hello, Mino. Hello, Eggy Nugget. Hello, Fairy Dust Transmission. Hello, Exposon. Hello, Nikki Paraforgon. Hello, Nobody Special. Hello, Mindforce. Hello, Pacham Senpai. Hello, Bob 10. Hello, Hero 37. Hello, Crypta. Hello. Today is a super exciting day because it's the very first HANDCAM stream. And it's going to be a little scuffed. It's already scuffed considering that I have only these cringe blue gloves. So you know my model has like black gloves, right? And turns out that I have no black gloves, and I was scourging everywhere last night with no success. So we shall see how this goes. Woohoo! So, yes, so today what we have on the itinerary, Immersion Ruin. No, we don't have Immersion Ruin. Just pretend that these are black, you know? Anyways, what we have on the itinerary today is we're going to be unboxing some of the gifts that were given on Throne. Thank you so much to the people who did purchase gifts on Throne. Super stoked. There's not really that much to unbox because I still am waiting for some things, but just wanted to highlight some new epic features. Yes, actually, you know the reason why these gloves are blue? It's because I'm blue shifting. That is exactly the reason why. Okay. Alright, first off on the menu is I wanted to show you guys my new microphone, which I used for the last stream, but I wasn't able to use for this stream because I am literally out of USB to USB-C converters. So this is the new microphone. Also, I'm wearing blue, like, underneath this, so I'm, like, completely blue right now. This microphone is some sort of, I forgot what type it is, but it's a Razer microphone. It's super cool. It's super nice because you can literally, first off, there's an actual mute button on the microphone itself. Second of all, there's some pretty sick stickers that it came with. So it literally looks like that I'm a pro gamer, right? What do you guys think? And for this one, huge thank you to Pogchamp Senpai. This microphone has been great. I'm still using my crusty Mac microphone right now, but for normal streams, I promise I will use this one. Blue www. Yes, perfect. Yes, baby's first microphone. This is my very first microphone that's like not my laptop, so very epic, very cool. Come on. Okay, but what I really wanted to highlight for today was this, the mystery item that I put on my Twitter X profile. And a lot of you guys were guessing, what could this be? What is this cursed object? Well, turns out this cursed object is actually a shy plushie. That's like the butt, that pink little thing. And this is the face of the shy. It has just been vacuum sealed into oblivion. So we're going to try to open this today using something known as fine motor skills. And maybe scissors. Ah! Come on. Okay, maybe I'll actually need scissors for this. Boop. Okay. Oh, okay, yeah, the scissors does help a lot. And then... Boop. Yeah, in the meantime, you guys should, I'm actually curious, what are your favorite plushies? I'm gonna highlight some of mine too, because I have a whole row of plushies above my desk. Release him. Release him from the void. Release him from the vacuum of oblivion. He's free! He's free! I've also named him Canis Major, by the way. Oh, a little crumpled, but free. A little crumpled. A little crumpled. Wait, he's so mini! Wait, I love this. This is... I don't know if you can see this, but it literally just says, like, made in China along the back. What if I could just, like, take that off? Or is this a permanent feature? Wait, I might need to take my glove off. Quaggon from Guild Wars 2. What does that even look like? You should put that into the Discord. I want to see what that looks like. A couple Hololive plushies? Whoa! Brachiosaurus I got at the zoo. Ooh. So I saw this meme that was like, every kid grows up as either a dinosaurs kid or airplane kid or like a Barbie kid. It's like, it's a 2x2 grid. I don't remember exactly what it was. Were you guys dinosaur kids growing up? Because I was definitely like an airplane kid growing up. Or space kid, I guess. Okay, fixed. A little. How do I like undo the wrinkliness? Like, look at this like spine. Dude has scoliosis. Dude literally has scoliosis. Maybe if I like, I have to like stretch the boy. This is a little fun though. Maybe if I put like water on it, it'll unwrinkle out. Or put it in like the laundry machine. Do you guys have any advice? Canis Major can walk it off. Well, this is Canis Major. Boop, boop, boop. Or it's probably more like this from your point of view, right? Boop, boop, boop. Boop, boop, boop. Boop, boop, boop. So adorable. So adorable. You know who this would go really well with? So, give me 1 second. Let me show you guys this abomination. So, oh wow. I look like I'm dabbing. What the heck? I also wanted to highlight my other shy plushie. Okay, it doesn't even fit in the screen. But dude is like this long naturally. Like, is very, very long boy. Look at that. Look at that. Look at how... I can't even show you guys, like, how long this guy is. Yeah, so this might be Canis Major. The other... Ah! The other one might be Canis Minor. Alright, I'll have to put this one back. Why does my model just, like, keep dabbing like that? Vacuum sealed squish. Needs some time to put. Tumble dry, low no heat in the dryer, or just leave it. Should puff up for the next day. Okay, I'll see what it's like tomorrow. And else I will tumble dry. Woohoo! Yay! So this is the very first gift. Canis major or minor. Woohoo! Okay, I shall leave this individual in the corner here with the other Zybe on my screen, you know, right there. Woohoo! Oh, I forgot to make myself some tea this morning. You know, my default nowadays has been this really, really nice Fortnum and Mason afternoon blend. If you guys have ever been, oh, my camera is glitching out. If you guys have ever been to London, I highly recommend you go here. It is really, really nice. Yeah, no, it's like one of my favorites for sure. Oh no, it seems like my camera is focusing and unfocusing out of view. Do you guys see that? Am I just tripping? It looks like my camera has like a heartbeat or something. Here, let me try I'm not sure how to fix that. Oh, I think it's good now. It might just happen intermittently. All right. I'm curious to hear about what your favorite teas are. I've been seeing really, really, really good teas actually on the Discord, which is really great. I have some bunch of loose leaf tea upstairs. Maybe I'll make some while watching. Ooh, that would be really nice. Oh, goodbye, Box Cat. Thank you so much for stopping by. Yay. Oh, this stream's current bitrate is lower than the recommended. Oh no. For some cool plushies. Small Gura plushie. Wait, I totally want to get a small Ame plushie. I don't know how many of you guys watched her graduation yesterday, but I was actually a little, I think I shed a tear or two. It was really sad. Ame has probably been, the VTuber. I mean, the entirety of Myth is what got me into VTubing, but Ame especially has been, sort of my favorite in the VTubing community, just because, I don't know, she's just really smart. She helps set things up for people and, so forth. So, yeah. I'm really sad about this. Yeah. I don't drink tea. Do Orbeez have any recommendations? I have a bit of a sweet tooth. Coca-Cola. Okay. But genuinely, I think, I don't know. If you like smoothies, there's this, juice called, Naked Juice that's, really good. I really like that. She made history, basically. Yeah, I know exactly. Yeah. Oh. Rip. But she did say that she might one day come back to streaming. So there's still hope. There's still hope. Who knows when? Who knows when? She'll be available with stuff. She's just not going to stream. Yeah, she's going to be working for Hololive, from what I assume, right? Okay. Next up is to get the whiteboard. So let me quickly grab that real quick. So this whiteboard was made possible thanks to Double Quill. Thank you so much. For getting this on the throne. It's been really useful. Oh, actually, maybe I should remove this bottom part. I'm disassembling this tray portion. So this is my abomination that I created. Oh, maybe I should, now that I'm thinking about it, this is actually backwards. This is my Borromean rings Among Us. So if you look at this closely, right? Basically, any two rings don't look like they're intersecting. But if you look at the system together, they are connected. How could that be possible, you may wonder? Topologically linked Among Us. Very beautiful. Alright, the one thing that I think I do need to fix though is that it seems like my webcam would be upside down. Maybe what I should do is try to rotate it on here. Or maybe I could just write upside down. Gave up on topology a long time ago. Yes. Maybe a tisane mix? Ooh, I don't know what that is. They always don't use tea leaves and I can have some sweet fruits in them. Maybe I should try that. I've actually never heard of that before. If you like Chinese tea, you can try Tai Guan Yin. I don't know if I pronounced that right. Which is regarded as the sweetest tea. You know what I should do? I should get like a sampler of teas and then just do like a tea HANDCAM stream where I have like the teas lined up and I'll like try each of them. How about that? That would be such a cool idea. The tea sampler stream, you know? Yeah, let's see what it looks like when I write something on this. I think it would be upside down. Yeah, it's upside down. Get a tea advent calendar. Wait, that's such a smart idea. Maybe I should try that. Okay, wait. I'm going to go right back. I'm going to try to find a way to make this right side up. I shall return briefly. Okay, situation is fixed. I will switch back to the webcam. Oh, I guess my... Here. Boop. Boop. Do you guys see that? Alright. Cool beans. I basically just had to flip the camera by reattaching it. So pretend nothing happened. Everything is lovely once again. Oh yes, please recommend me any sites. Send them to me on Discord, Twitter, whatever. That would be super duper cool if we could do like a tea ad. Speeding at sea, it's me Z. Today we'll be trying out tea. Yes, exactly. Oh, hello Tika. By the way, the Canis, I guess this is Canis Minor now, turns out, but Canis Major, Shibe, arrived in the mail, so here it is. A little wrinkly, but very squishy indeed. He will be watching over us as we do integrals this fine morning. Okay. So, are you guys ready for some integrals? Wait. Drum roll. Alright, because I am very, very excited. This is a really good whiteboard. It also came with, like, markers, too. Goodbye, Baromian rings among us. Hello, integrals. Okay, let me grab my marker. Okay, so I did think of a few problems beforehand, and I found some of these online, and I think the integrals are pretty chaotic and very reasonable. And some of these are actually some of my favorite problems of all time. So, without further ado, let's get started. No, don't be angry that it's integrals. Integrals are very epic. Okay, here's the deal. For every integral we do, we could do a fun task with it. I need to brainstorm a list of fun tasks, but maybe class, you can brainstorm a list of fun tasks that we can easily do as a HANDCAM stream. I have no idea what integrals are. Okay, so what integrals are... Here, let me let this... The webcam is blurring out now. Boop. Okay, what integrals are is that you could do... It's like this symbol. And you know when you take... Okay, so you know when you have an equation like this, you find the slope. The slope is constant. So maybe the slope is 1. So maybe the slope is 1, right? This is finding the derivative, because you're finding what is the tiny bits of slope along this line. Now the integral, oh, I should have just kept that, by the way. The integral is different. We're basically finding the area under the curve, but for tiny bits. So you probably have the function in here, f of x, and then you have dx. The dx represents that we're doing tiny bits of the area under the curve. So maybe this is dx. And if you make dx infinitesimally small, you can find what the area is under this curve. So actually, to make things easier, I'm not just gonna start by just like doing random integrals. I'm gonna be doing integrals that are sort of more related to physics. And we could do advanced examples, right? Yeah, like a summation, but you have infinitely small pieces. So the really cool part about these is that you can really use them in different aspects. So let's say that we have a curve, a rod, that's given by the function x of t is equal to t minus sine t, and y of t is equal to... I love how I go from like, yes, this is what an integral is, and then jump straight into, okay, let's say we have a parametric curve. We can do a fun little derivative every integral. That works, yes. Okay, and we have 0 go from t to 2 pi. So that's sort of our setup. We know that this rod, or this like curve, I guess, has density, that's a rho, by the way. This is a rho of k, a constant density k along its curve. And so the question is, what is the mass of this curve? And what is its center of mass? So we can go about this in a pretty long-winded way, but I just wanted to do fun, cool integrals. Maybe. I don't know any pen tricks either, so this is gonna be kind of mid. Oh wait, hold up. Yeah, I only know this pen trick, but that's sort of our setup. So let's get integrating time. So I guess I'll just like leave this in the corner. Okay. Cost tan meme. I have not heard of that. But it's probably like the shika noko kosh tan or something like that, right? So the mass, so given the density, we can actually find the mass pretty easily. It's by taking the integral of the density along the curve. Where this is a density, these are little bits of the curve. And so when we find the little bits of density at each part of the curve, we can sort of put those all together to get the mass. Okay. There's so many integral memes. Oh, I should probably play like an integral song. What music do you guys listen to while you integrate? What music do you listen to while you integrate? Okay, let's get started. So what is the mass of this rod, right? So we start out with this equation. But because we are using t, the parametric form, what we have to do is actually convert ds into a way that describes the curve in terms of t. So how might you do that, you might ask? Well, we know that if we have x, y, the length along this curve is basically like x squared plus y squared, right? So we can actually describe ds as root x prime t squared plus y prime t squared. Oh, my handwriting just died. Y prime t squared dt. So this is basically using Pythagoras' theorem. Okay, now it's time to integrate. So given that we know that t goes from 0 to 2 pi, our density rho is k, we can actually just plug and solve 0 to 2 pi, and then k times x prime of t squared plus y prime of t squared dt. But we know that x and y of t are defined by these equations so that we can put them into here. So what is, I guess we'll have to do some differentiating first, right? What is x prime of t? It is 1 minus cosine of t. What is y prime of t? It is sine of t. So m is equal to, putting that all together, it is k square root of 1 minus cosine t squared plus sine squared of t. Oh no, it's okay. Like that. Plug and chug. Plug and chug. It's okay. Life is daijobs. Okay. But this is ugly, so we gotta expand this out, right? So it's 1 plus 1. So if we try to take and look and see what's inside this, this is 1 minus 2 cosine t plus cosine squared t plus sine squared t. But this is actually equal to an identity. This is actually just 1. What? So this is actually 2 cosine t under the square root. So we've simplified this abomination into something that's a lot easier to read. Wahoo. Okay, so that was a lot of chaos. So now it's just time to plug and chug. So if we want to find the mass of the rod, we're basically finding the density along every parts of the curve, which we described as ds. But now we sort of have simplified that even further, so our integral is simply just 0 to 2 pi k of 2 minus 2 cosine t to the square root dt. So that's basically the integral that we have right now. So we're trying to find the mass along this curve. So you might be wondering, what is this integral equal to? It's chaos. It is very much chaos. So we can sort of go about by doing that this way. Well, we have to use are some trig identities, so Mind Force, you are totally right. What I like to do is that we see both a 2 and a 2 in here, right? So we can actually probably try to take those out. So that would be... And k is a constant. So if we have 2 and the square root here, that basically means that we can take out a square root of the 2k. So square root of 2k, 0 to 2 pi. And that gives us 1 minus cosine t to the half dt. Okay. But then, in order to solve this one, we actually need to expand this in a weird, funky sort of way. Wait. How do you expand this again? 1 minus cosine t, so you probably have to put a sine t next to it somehow. 1 minus cosine t to the half. Ah, I see. So we actually should be recognizing this as a trig identity. So we know that square root 1 hold up, square root 1 minus cosine t should be, I'll have to Google my trig identities, Lamel. Bro, even, it's okay. Everybody has to Google trig identities. 1 minus cosine t is equal to 2 sine squared t over 2, and that's using the double angle formula. Yes, let's just pretend that just is, because I really dislike trig identities as well. So, putting that all together, we would then get square root of, so that would actually be 0 to 2 pi, square root of 2, sine t over 2. I've always hated trig. No, it's okay. Trig is necessary. Trig is necessary for life. It's okay. It's dijobes. Okay. And so we can take out this constant once again, and then do 2k, 0 to 2 pi, sine t over 2 dt. Oh, and then this is a much easier form for us to actually solve. So, k squared, so is equal to 2k, so that should be 2 yes. So what I did just now was that I integrated it with respect to t, and so the integral of sine is negative cosine, but because of this t of 2 factor in there, when we take the derivative of this half would go outside, and so we need to balance the factor outside here too. So negative 4k cosine 2 pi over 2 minus cosine 0, and if we were to solve that out, cosine pi is negative 1, cosine 0 is dun dun dun. Wait, I just got 0. Wait, that's not true. That is not true. You have to leave for work. Goodbyes. Goodbyes, have fun at work. Hopefully this didn't cause your brain to explode. Oh, speaking of brain, thank you so much to Eggy Nugget for providing this amazing big brain for me to use during my streams. Very beautiful, very demure. Wait, cosine of pi. Cosine of pi is -1. Cosine of 0 is 1. What? Or maybe I just did not deal with this negative sign properly. So if we just keep it the same. Okay, let's backtrack. Let's go back to this original step. So 2k times, it's basically -2 times cosine of pi is -1 plus 2 of 1. Okay, wait, that is not 0, which is 2 plus 2 is 4 times 2k is 8k, which I believe is the correct mass. Yes, that is the correct mass of the rod. We found the mass of the curve. We found the mass of the curve. Ignore the fact that I literally got 0 for a second. Oh wait, no, this is a smooth brain. I need a super duper wrinkly brain. You know that the, okay, I don't think this is actually true. Maybe Faye, you know, the bio VTuber, can figure this out. But I think if your brain has more wrinkles, it has like more storage. So yeah, maybe I need an ultra wrinkly brain. Jump started the brain for your day. Yes, exactly. This is a good mental warm-up. You should wake up, no coffee. You should wake up and solve integrals right away. That's so funny. Well, that was a bit of a process. So, okay. As we take a break from integrals, I do want to show you guys my amazing hand sign. You might be wondering, what is this weird gangster sign that Z is throwing up? This is an Among Us. Do you see it? Among Us hand sign. Dun 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 dun. This, but I don't think this is the imposter because it's blue. Yes, very epic. You need to stop, sus. No. Hi, now I'm doing approximation theory problems. Wow, so this must be light work for you then. We're just doing integrals here. We're doing integrals. With the hands too. Among Us. Do you guys know that one like song? There's like this one K-pop song. This might totally fly over everybody's heads. But it's like, this time I want you, like it's magnetic, you. It's called Magnetic by Islet. I don't know if I can play it without a copyright strike, but maybe that's a good idea. Wait, hold up. Let me play it real quick. I'll be right back. Where is my second device? It is right here. Boop. I've returned with the device. I'm gonna have to look up this song because this is one of my favorite songs of all time. Oh my god, guys. Wait, this is so random, and I probably don't really talk about my things like this, but I just got selected to give a talk. Let's go! I just saw my email like pop up on the top. Let's go, that's such a victory royale. Okay, that really made my day. Let's go! What's with the wild hand signs? It's just kind of fun. It's fun. Okay, hopefully I don't get copyright strike for playing this song. Where did it go? It's called, oh my god, it's called Magnetic by Eyelet. And it's actually perfect because magnetic is like you know, magnets. It's physics, right? Okay, hold on. Okay. Oh, that's not the right song. Okay. Okay, I only like the chorus though, so hopefully this is not too loud. I love this song. This time. Let's go. This is our Victor Royale song. After we just finished our integral. Hopefully I don't get copyright strike for that. But we ball. We need a congratulations song. Let's go. Let's go. I kind of like J-pop more than K-pop. Ooh, I've been listening to Yoasobi a lot recently, like Idol and those kinds of songs. So yeah. Okay. Now that our celebration period has ended, we must continue with more integrals. So, alternatively, okay, so we have two options. We can continue with this rod problem and no longer find its mass, but just find its center of mass, like the exact coordinates of its center of mass. Or alternatively, we could find the length of other curves. Or, let's see, I had a few questions saved in the case that you guys wanted a variety. Or we can just do like a straight up like plug and chug integral, which is a little painful, but it would be cool. Here, let's do a poll. Let's do a poll. So, what integral would choose your integral? Choose your integral. So we can do center of mass of this curve, length of curve, plug and chug zen, not so zen integral. A cozy integral. Never said that in my entire life. Or plug and chug polar coordinates integral, which is like really painful. So which ones would you guys like to see? Go vote, go vote. And in the meantime, drop your favorite song that you like to listen to when you do physics. For me, I really like Eyelet's Magnetic. But it can also vary. I feel like it can also vary. Boop. You know, I was wondering, why do VTubers always wear gloves when they do HANDCAM streams? Is this just a naive question? Can somebody who's like more experienced than me actually answer that? Because I genuinely have no clue. Is it like an identity thing? But like, I don't know if anyone can recognize somebody via hands, you know? Lo-fi. I used to listen to AKB and so. Oh, you mean like the huge like idol group? They are amazing, but it's like, it's so crazy. Maybe they have tattoos. Oh, there's a chance to get doxxed. Oh, but the gloves add to the anonymity and immersion. Yes, this is the immersion. I am 1000% immersion. My favorite song is Technor, or just favorite song of a certain type. If you had to do play one song for the rest of your life, what would it be? I'll listen to Technor. I'll do that too. I know that there's somebody in the Discord who really likes The Who. It's like this band group. Their username is like Pete, but it's like spaced off with like different characters. So it's like, yeah, I think it's like Pete or something. deterrence from, ooh, I'll also jot that down. Ramstein. We gotta drop all these bops. Yuki, 10 hours. Merry Christmas. Merry Christmas. Wow. No, the Christmas music is kind of a banger though. Yeah. Okay, let's look at the poll. Wow, you guys really like to make me suffer. Polar coordinates is in the lead. Polar coordinates. Dislike. L. I love tattoo from Ramstein. Ooh. Merry Christmas, sister. Okay. If we're gonna do a polar coordinates integral, let's get started. Actually, to make this even crazier, this is actually a double integral. So, we are given this scenario. We have a sphere, x squared plus y squared plus z squared is equal to 4, and we have a cylinder is equal to 2x. So what that looks like is actually like, this is a really poor diagram. It's a cylinder standing inside of a sphere. So what we have to do is find the area within this cylinder bounded region. So yeah, this is going to be a little painful, but that's okay. So what we have to do first is we need to convert into polar coordinates. So this is r squared is equal to r cosines. So we can actually convert each of these aspects. So we start with x squared plus y squared. We can say x squared plus y squared is equal to r squared. But x is also, so in order to convert, I'm using these notations. Z is equal to z. And so when we convert this, we know that x squared plus y squared is r squared. So we have r squared, here, let me get this out of the light, is equal to 2r cosine theta for the cylinder. And r is equal to 2 cosine theta. So this gives us a bound on r. I love tattoo from Ramstein. Ooh, I should listen to all these songs. Please drop them in the Discord. I've been looking for new music. I think Pembu dropped a new song by Cynthian. It was so good. It was like, it's probably my top played song right now. Very, very, very good song. Okay, but to convert this one, it's a little bit different. So we don't have a z variable in this case. So what we actually need to do is say, move things to other sides and say that x plus y squared, x squared plus y squared is equal to 4 minus z squared. So this is helpful because what we have to do is actually convert these into polar vectors. Very, very crazy. So r xy form. So this is what we have for the sphere. Okay. Very crazy. Very chaotic. Not very demure. Ramsey is a German rock band. I don't know how much Z would like it. I actually do like rock. If you guys have heard of Two Door Cinema Club, they are one of my favorites right now. I really like Smoking in the Theater, Undercover Martin, What You Know. I don't know if they're rock though. And German rock I also feel like is probably really different. So, I don't know. Who knows? Who knows? We'll find out very shortly. Okay, so moving on. If we want to find the area, what we actually have to do is take the cross product between the x and y components of this vector that describes the sphere and integrate over the cylinder. So what might that look like, you might say? So Rx, Ry. So we gotta separate this into their x and y components. So we start by looking at just x, so we can say y. x is 1, y is 0, and say, what do we get out this way? And basically, what we have to do is take the derivative with respect to x. So that is, oh my god. Guys, this is so painful. 4 minus x squared minus y squared to the half is negative x. 4 minus x squared minus y squared to the negative half. Now we gotta find it with respect to y, which is actually, since we've already done this, it's not that painful because it's the same just with y at the front. Oh, already so exhausted. Already so much pain. Ram from Ramstein is read normally. Einstein? Stein? So it's Ramstein? Ramstein? Am I saying that right? The song was about a year old, but it's very good. Yes. I will listen to all of these songs. I got it. I got it. Power through. Power through. Okay, so next step is, now that we have those two, what we actually need to do is take the cross product of them. Why, you might ask? It's because the area that we're trying to find is defined as TU cross TV dA. Well, in this case, we can actually just say that's RX cross RY dA. Very beautiful. So let's find the cross product. So in order to do that, I like to employ this like really cool table method where we put in the different, so we put in RX on the first row and we put in RY in the second row. Zero, 1, negative y, 4 minus x squared. Yes. Oh. Why don't I use some kind of software to draw? You know, that would be really great. Except that I got this brand new whiteboard and I wanted to show it off. Also, I have been using this to solve problems and it's really nice. So I just want to do something interactive while chatting. So cool stuff. Okay, this is gonna be very, 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 very painful. The people who voted for polar coordinates, you are on my hunting list. Please save me. Okay, it's okay. You know, the thing about these is that, you know, in the process it's painful, but when you emerge out of it, it's okay. So the first one is I, which means you need to actually subtract. So x minus 4, x squared minus y squared to the negative half. And then you cross these two, which is y minus 4 minus x and 1. Yes, but you know what this means? We need to find the magnitude of this thing. Pain, suffering. It's okay. Thank you, Malko Vilev. You're removed from my hunting list. So when we actually solve this out, this should be equal to x squared plus y squared 4 minus x squared minus y squared. Negative half squared should be negative 1 plus 1. There we go. Okay. Very epic. So that's what we got. So now it's time for us. We can convert this into polar coordinates, and then we gotta solve this integral. So x squared plus y squared is r squared, and then 4 minus x squared minus y squared is r squared minus 1 plus 1. So I think that is our integral. I mean, we could technically simplify even more by taking this out or whatever, but it's okay. It's Dijobs. It's Dijobs. So Now we take this. Now we take this, and we actually need to integrate over it. So before I found the bound on R, we need to use that to integrate over time, over the area. So the area is equal to, so since it's a cylinder, we go from pi over negative pi over 2 to pi over 2, and then we go from 0 to 2 cosine theta, and then we gotta plug this monstrosity in. Maybe there is actually a way to simplify this further. So maybe we do, so this is basically the same as 4 minus r squared. And then if we need to add 1, like that, and then we can do 4 over 4 minus r squared, which is, I should get a bigger whiteboard. Don't be sad that it's polar coordinates, be zappy that it isn't spherical. Okay, at least it's not spherical coordinates. That is true. That is true. Hugh, I'm just here to chill. Honestly, I think that's what this is gonna be. A chill stream while I suffer in the background. Integration by parts is the way. Integration by parts. I mean, I think we can simplify this even further, right? Because we can do, this is basically 2 to the 4 minus r to the negative half, right? Yeah. So this is much simpler. I hope we won't need that. Well, but let's see. My brain is very fried because it is, I basically woke up at 7:30 a.m. in the morning for this stream when I typically wake up at 8:30. But, you know, anything for the integrals. You talk like a, what? Visible confusion. Kegen Church Gilbertjate. I don't know how to pronounce any of these German words at all. So, we'll see. But please link them into the Discord. Please link them into the Discord. May I ask where you park your TARDIS? May TARDIS? What? Wait, who has a TARDIS? What? Okay. Okay. Let's see. Next step is that we actually have to do this integral. So we have to do, so the dA component, so this is dA, we have to do it in polar coordinates, so it's r d theta. Okay, next step. I think that's a Doctor Who's reference. Should I watch Doctor Who? I have so many shows on my to-watch list. There's a show I've been watching called The Good Place. It's like a POV of like somebody who dies and they go to like the good place, but it's like not what they imagined. So yeah. Let's see. Yes. Oh, what am I looking at? Yes, we're trying to find the area that is encapsulated by this part of the sphere. So, there are many valid. What do you think is the best season of Doctor Who? So that I can watch one and try it out. I feel like as a nerd, I would really like Doctor Who. As a nerd, I've also really liked watching Gravity Falls when I was younger. That was a really good show. Okay, now it's time for us to actually solve this integral. So let me actually erase some of this like setup type stuff. Boop. So this is 2. Okay, so this is our setup. We're gonna need a lot of space for this, so I'm gonna write really small. Start with the reboot. Is there a specific channel? Yes, there is a music channel, actually. Gravity Falls was a great show. Yes, wish they would continue. I think they will, though. I don't know if you guys have noticed, but they have been, like, teasing. They have been teasing something I don't know what it might be though, so we'll see. Okay. So, this is our integral. Let's solve it out. So first we gotta integrate with respect to theta. There are no theta terms in here, so I think we just go from 2 cosine theta to 0. So, okay. Oh, wait, no. The 2 cosine r is equal to 2 cosine theta. So we have to integrate with respect to r first. So, okay. Let us solve this out. So there is a 2, so this is basically the same as this, right? So 2r. So what we have to do is kind of the reverse chain rule. What we have to do is that we actually have to move this negative r squared out this way. So in order to do that, maybe we do 4 minus r squared. We need this root to be positive half so that integrates to negative half. And then we need, so that we get negative 2. So then we need a negative sign out front. And we need a 2. I think that is correct. Okay. From 0 to 2 cosine theta, d theta. Okay. Yes. I started with the reboot and watched 30 episodes of the first Doctor. The first season was the peak. Okay. Maybe I'll try the first season and everything after the reboot with the 9th Doctor. Maybe I should try that. I have so many shows to watch. But it's okay. Actually, in the span of 1 month, I watched the entirety of the 9 seasons of Game of Thrones. Which was a lot, but that also shows that I go through shows really, really, really quickly. I just want an hour-long 20 years later where we see loving every minute. Wait, no, I think Mabel would not be happy at a dead-end office. Wait, did she ever say that she wanted to do that? I don't think I watched the entirety of Gravity Falls. Like, I only have watched, like, every single episode, you know? So, okay. I'm gonna keep working on this integral. So, we're gonna plug in 4 minus 4 cosine squared theta to the half minus 2 plus 2 4 to the half d theta is equal to, okay, let me be conservative with space, so let's go this side. Negative pi over 2. So this becomes 4. First episode of Doctor Who is really old. Some of the episodes are missing from the internet. Oh, well, I'll look for it. Yeah, we're doing integrals for a cylinder and a sphere. We're trying to find this area that's like encapsulated by the cylinder. So this would be negative 2 4 minus 4 cosine squared theta to the half plus 4 d theta. Okay. Very epic. Oh, but we know that sine squared theta plus cosine squared theta is equal to 1. Or maybe we can convert this to sine squared theta plus 4 cosine squared theta is equal to 4. So this is actually just equal to 4 sine squared theta. Good morning, gamers. I'm not gaming today, though. Actually, you guys should help me vote on what my stream should be for this Saturday, which I think will be my next stream. I think I might continue playing Superliminal, which was pretty nice, and huge thank you to Faye for also like my very first ever stream raid, actually. So that was really cool. But yeah. Okay. Gotta convert. We're just finishing up this integral to find the area encapsulated of a sphere in between a cylinder. So this is negative 2 4 sine squared theta half plus 4 d theta is equal to So this would go to 4 theta. So we need to move this down. Oh no, wait, this is a little, wait, let's see if we can try to simplify this a little further. Sine theta. I'm very close to unlocking Stream Redux myself. Wait, how do I do that? Wait, I'm such a noob at technology. Wait, I'm such a noob at Discord too. I'll have to try to get Discord like premium or something like that. Yeah. I think this is -4 sine theta plus 4. Yes. So if we were to integrate that, that would be 4 cosine theta plus 4 theta, -pi/2, pi/2. So that would go from, so that would be 4 cosine theta vertical is 0 plus 2 pi minus 0 minus 2 pi. Oh, shouldn't forget about this. Is equal to, wait, I already incorporated that in here. Is, yeah, there's rumors. 1,000 subscribers unlocks redirects. Wait, we're so close to 1,000 subs. That is actually so true. We are very, 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 very close to 1,000 subs. 2 cosine theta plus 2 cosine. So that gives me 4 pi. 4 pi. Oh wait, the weird thing is that the actual correct answer should be 4 pi minus 8, so I'm forgetting something here. Let's retry. So -2 for sine squared theta is, so that would give me 2 sine theta, which multiplies to -2 sine theta, plus 4 theta. What is going wrong here? Did I get the bounds incorrect? Is it from 0 to pi/2 instead? Wait, give me 1 second. Let me think about this. Big brain. I need to think. I think what we have to do is, because we go from -pi/2 to pi/2, there's actually a symmetry that makes this not necessarily go to 0. So what do I mean by that? So it means that for this term, this is fine, but then we do pi/2 here and then multiply by 2. So we actually need to catch that symmetry, because it wouldn't necessarily cancel out. Sorry, I'm just talking to myself. I want to solve this. I want to solve this. Okay. So the vertical pi/2 would then be, yeah, let's see. So that would give 0 minus, that would give us -8 plus, and that would still give us 4 pi. Because this term gives us, so, okay, let's backtrack. So this gives us 2 times 0 minus 4 plus, and then this term would give us 4 pi, which is 4 pi minus 8. Okay, let's go. That's so weird about the symmetry. I should be able to catch that next time. But let's go! Another... So this area is 4 pi minus 8. You might be wondering, how do we use this in real life? I can't think of a reason to use this in real life for now. But yes, this is what I have. Very beautiful. My brain is so fried, guys. I feel like I haven't like properly sat down and done integrals in a really long time. Yeah, no, this is fun. Exactly. Now, what I'm hoping to do with this whiteboard is not just like ramble on and do integrals for like life's existence, but rather to actually maybe like teach something, you know, like maybe like quantum physics. Maybe we can learn about like up and down states and stuff like that. I did a video on the Clebsch-Gordon coefficients, and that was actually one of the big hits of like my YouTube shorts. If you haven't already, go check that out. I'm actually creating some more YouTube shorts right now. Draw an Among Us, please. Should we draw an Among Us to celebrate? What do you guys think? Maybe we should draw an Among Us to celebrate. Wait, hold up. I want to pose. Pose. Okay, I'm gonna send that into the Twitter later. So I'm doing a short on one of the largest numbers in math. It's actually really cool. I've actually been learning so much. And I also made some really funny clips of my superliminal stream, so I'll be posting those as well too. Kim During didn't vote on anything. Yes. Maybe we should draw amogi just to chillax our brain a little bit, right? Googleplex? Nope, it's not Googleplex. I think it's actually larger than Google. I don't know if it's larger than Googleplex. I mean, actually, this number is actually so big that if you were to think about all the digits in your head, there would be so many bits of entropy that your brain would literally turn into a black hole. Literally turn into a black hole. It's one of the coolest numbers that I can think of. So yeah, keep an eye out for that YouTube short. It might be sometime in the next few weeks, along with my other like stream clips. So yeah. So let's draw an Among Us. So, you know the typical Among Us is really just like this, right? Like that is just the typical Among Us. But there are many, many different varieties of Among Us. My favorite personally is this one. Oh, my camera is like out of focus. But this is a long Among Us. Boop. And then I also like this one. Yeah, for everybody who voted on the polar coordinates integral one, jail. Jail immediately. There's this woobly one. There's also this one that I like to draw. So if you see any of these around, you'll know that I have graced your presence. Longamugus. Why not long body and short legs? I mean, I could do that too. There's so much creativity. Like this? Oh, this one's a little wobbly. This one looks kind of like a vase. It's a terrible day to have eyes. Wait, I should show you guys my, like, most cursed, Oh, yeah, wait. I was gonna do another loop, but this also looks very cursed. Or you can do, like, maybe a whole grid of them. Or even nowadays when I see like something like this, even a fire alarm that looks like this, I'm like, Among Us. Amogus. There's also like cursed amogi, but yeah. Very epic. What do you guys think? Which one is your favorite? Maybe I should do another poll. Favorite amogi. Long amogi. Spider amogi. Many-legged amogi. Fractal amogi. There we go. Comb amogus? Sent a link to an amogus song. Oh no! I've been hearing all these like cursed remakes of like existing songs. Biblically accurate amoga. I could try to draw that. Here, let me delete spider amoga real quick. Like, you would have to start with, like, something like this, right? And then have, like... the backpacks. I'm trying my best. And then maybe we need like so that they're like actually like differentiable. Oh wait, instead of doing that, maybe I should have their legs here. Ah. Oof. As you guys can tell, I'm definitely not an artist. Something like that? What do you guys think? Biblically accurate amogi? Chalk your song, not an oh, I see, I see. Very cursed. Yes, Uzuyami, very cursed. Donut. I could just like... Very scrumptious. Wait, I should actually show you guys. I literally made a mug. This is really worn out, by the way. But I made a mug before where I drew an Among Us. It used to be much more crisp. It's worn out with time. So yeah. I don't know why my obsession with Among Us is a thing. So, yeah. Oh, it kind of looks like the sandworm from Dune, not gonna lie. You can use AI art. Ooh, I mean, you could totally make an AI art of an Among Us. You know, it'd be really cool if for my model, like, you know, this is me, right? You know, this is me, right? Right? It'd be really cool to just have, like an astronaut helmet and, like, a visor where my head sticks out. Eggy Nugget, where are you? It's time for you to cook. I'm calling on you. Yes. Oh, this is hilarious. Okay, I only have a few minutes left, but yes, this is my collection of amogi. I hope you guys liked the very nice fractile amogi seems to be in the lead. Hope you guys really enjoyed that. You can put amogi on your dress. Oh yes, I do have like 2 new outfits. So yes, for next Superliminal stream, I'll probably wear my cozy outfit. This is mostly for like my educational outfit. You can put amogi on your dress, sure. Maybe what I should do, here, let me erase this so I can like visualize what I'm talking about is like, so this is me, right? Okay, this is like really cursed. Okay, that does not, why are my legs like that? This is me, right? This is me, right? I don't look like that at all. But maybe instead of having this like skirt CMB combination, maybe I can do like have this be red and just be like an Among Us. Or I can make like an astronaut outfit that's like that and like an astronaut helmet. What do you guys think? Astronaut Z in an astronaut fit? Astronaut? Maybe. I think that would be pretty sick. Okay. Alright. I think the stream is coming to a close. Let's see what time it is. Yes. Okay. Yes, I will have to depart soon. Cosmonaut. Okay, that's actually better and probably easier to say than astronaut. Curse prompt from image generators. Please send into the Discord. Lobe? I don't know what that is. Maybe you should send it in the art channel so I can check it out. Anyways, do you guys like this type of stream? I can do more of these. I know this was probably really disorganized and just integrals, but I'm hoping to do maybe more of these. I mean, unboxing was super cool. For those of you who missed it, new microphone, super cool, very epic. I'm thinking we could do like a Lego building stream. And the reason for that is because there is a Lego set that is en route to my location. So that would be really, really sick. Really chill, really chill. Do you guys like it? It was fun? Okay, great. I think it's also fun to just chat with you guys, and also I feel like my model does have like expressions and it does have hand tracking, but like in general, I use like a lot of like hand held gestures. So yeah. Do you ever receive that astronaut lamp yet? Oh, I think it's actually en route right now. But once it does. I also received a really, really nice, really adorable keyboard mat that looks like a space window. So I'm really hyped for that. I love maths, so of course, yes. Maybe next time we should do a bit of physics. Wouldn't that be sick, right? Maybe I should teach you guys partial differential equations. Who knows? The world is your oyster. And if you have any video ideas, please do not hesitate to suggest them. Okay, I think that will have to be the end of this stream. Canis Major? Minor? I think Canis Minor is a more appropriate name, considering that I do have a long shibe. But I have a weird feeling about calling it Canis Minor. Maybe I'm thinking too deep into this. What do you guys think? Anyways, Canis whatever. Canis Z. Or Canis... I don't know. We should think of a name. But Canis Major, Canis Minor says, "Thank you so much for showing up on the stream." Okay. Canis Small? Yeah, Canis Small. That's such a cute name, yeah. Canis Small says, "Thank you so much for coming into the stream." I study in physics science, by the way. Really? Me too? If you haven't been able to tell already. Doggy no. Oh, that's also cute. Maybe we should do another poll to vote. Boop. I'm gonna boop the snoot. Boop. Alright, thank you guys so much for coming to my very first HANDCAM stream. I hope you enjoyed. I hope you liked the integrals. I hope you liked chatting. I hope you liked everything. And please do not hesitate to give me more ideas of how we could do more HANDCAM streams, because I'm super stoked to do more. Okay. Bye-bye. 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 Bye, class. Stay hydrated. Stay safe. Stay amogified. Stay amazing. I will probably take pictures of the coffee I get later. Bye-bye. Bye-bye. See you later. See you later. Bye-bye. Bye-bye. Okay. I need to actually use my hands to end the stream. But bye-bye. See you later. Bye, class. Bye-bye.